So, hello everyone, and welcome to this awesome stream on Cluster API Deep Dive with Jason. So, those who are new to the channel,
And welcome to this
my
awesome
name
stream.
is Sai Pathak, and I do cloud native streams on my YouTube channel, where I, bring awesome people with me, and we talk about cloud native technology, try to do deep dive session, production ready sessions, and so on and so forth. So if you are new to the channel, definitely care to subscribe and press the bell icon because there are tons of stream in the coming months. So I think you don't want to miss that. There are awesome open source tools that have been launched by Rancher. So I'm having a Rancher Super Stream Week, 5 days of all the awesome products. I just tweeted that out. And yes, for each show there will be a swag giveaway that I'm trying to do. So there's a Google form that I'll be sharing now in the chat, so that you have to fill that form to be eligible to enter the swag giveaway. So I have shared that. Make sure you fill the form, the Google form, and make sure we have all the. Just a second. Yeah. So make sure you fill the form, and then only I'll be able to pick up your name if it comes. And another thing is that there are a lot of streams that you need to that you can learn from the past streams. Everything is recorded. If you're watching again, it's completely fine. And today we'll be talking about cluster API and some of the production things that that are very important from the community aspect. Community has asked a lot of times, like there have been, whenever you talk about the production clusters, so there is always a mention of cluster API. So why is that, and how, what are the different scenarios where we can use cluster API for production? And yes, Jason is there with me today. So Jason, welcome to the stream. Thank you for giving your time, and please introduce yourself and say hi to the community.
Yeah, thank you for having me. So my name is Jason DeTiberus. I'm currently in Equinix Metal, building out basically cloud native management of infrastructure in a data center now. I've been involved with cluster lifecycle management for Kubernetes since I think 2015 now. So going on, it's 6 years now. I can't believe that. That seems crazy to me. Anyway, so most recently, most folks in the community will know me from the work that I've done on the cluster API project, and which is what we're talking about today. I've previously been one of the maintainers for the project, recently stepping back from that a little bit as I focus a little bit more on the bare metal aspect with some of the stuff that we're doing with Tinkerbell at Equinix now, and we'll get into that a little bit later as well. But again, thank you for having me, and I've been looking forward to this.
Awesome. So now we'll directly get started. No more wasting of time. So today's topic is obviously cluster API. So we'll be starting with the introduction to the cluster API. Look at some concepts, some architectures. So Jason will be doing. We'll be doing a conversational style, but Jason have some slides as well and a demo. So we'll try to do mix and match of everything. And make sure you ask your questions, because those matter a lot. So whatever questions you have, put them in the chat, and then we will answer them. So stage is all yours, Jason.
Yeah, so in general, what is cluster API? And to give you an idea, when we started down the path for cluster API, the whole goal was to see if we could build out declarative lifecycle management for Kubernetes clusters using the same Kubernetes primitives that people were building declarative management for applications with. And you might think that seems a little weird to use Kubernetes to provision Kubernetes, and in some ways it is. But at the same time, we wanted to make sure that we weren't building out two different types of cluster management. Because if you have one way to manage a cluster once Kubernetes is already up and running, because you don't want to necessarily manage two different declarative management systems, one for your applications and one for your infrastructure. What a lot of people were doing was basically, once you got things up and running with Kubernetes, you'd manage Kubernetes with Kubernetes. But to bootstrap it, you would use a completely different system. So the people building out this tooling ended up having to manage two different, lifecycle management tools, one for bootstrapping the infrastructure and then one for managing the infrastructure when it's up. And we wanted to try to avoid doing that. So we have kind of ways to work around that by using, like a bootstrap local Kubernetes cluster to stand things up originally, and then you can migrate things over. And we'll get into that a little bit more as well. But, going back to what is clusterAPI, since we're talking about declarative management of Kubernetes clusters using Kubernetes, probably the first two concepts I should introduce is what is a management cluster and a workload cluster. So in this case, a management cluster is the Kubernetes cluster that you're using for managing other Kubernetes clusters. This could be a self-managed Kubernetes cluster or just a dedicated Kubernetes cluster for managing other Kubernetes clusters, but it's running the actual clusterAPI components itself. The other concept is a workload cluster. That's basically a Kubernetes cluster that's being managed by clusterAPI. So at a very high level, it's just, and since we're talking Kubernetes here, we're basically talking about some declarative YAML configuration. You take that, you throw it at a management cluster, and out the other end, you get a Kubernetes cluster that's running somewhere. We have various different pluggable infrastructure providers for clusterAPI. So that could be running in Azure or AWS or vSphere or even Equinix Metal if you want a bare metal, infrastructure provider. The idea, though, is that at the end of the day, you're using a common language and a common interface to interact with these Kubernetes clusters. So wherever the Kubernetes cluster is running, you have the same type of interface to it. You can do the same type of high-level operations. How do you scale that Kubernetes cluster that's running in AWS is the same as you would scale that cluster that's running in Equinix Metal or Google. And then you can start building out higher level things. Like one of the things that we have is integration with the cluster autoscaler with clusterAPI. So you can autoscale these clusters in the same method that you would any of the other clusters. You don't have to configure a different autoscaler for each different environment. It's the same type of autoscaler configuration. I do see somebody mentioning in the chat that VMware Tanzu is entirely built on clusterAPI, and that is correct. And one of the other interesting things is the more products that we see that actually get built out on clusterAPI, that means that you can then interact with these various different Kubernetes distributions in the same way, not just different infrastructure providers, but you can operate a vanilla Kubernetes cluster the same way that you operate a VMware Tanzu cluster. And that provides a lot of power to users in that, we talk a lot about no vendor lock-in within the Kubernetes community and being able to migrate your workloads between different Kubernetes distributions and vendors if you wanted to. With products that are based on clusterAPI, you can actually migrate your infrastructure management in the same way between the different vendors. And going back more into how it does this, like I said, we have various different pluggable providers for the different aspects of clusterAPI. So within that management cluster, you have the core controllers for clusterAPI. This provides the high-level management of the very basic primitives in clusterAPI, your cluster, your individual machines, things like that. You have the Bootstrap controller manager. This allows you to basically swap out, what type of Kubernetes are you bootstrapping. Right now, upstream, we provide a kubeadm-based Bootstrap controller, and that allows you to basically stand up kubeadm-based vanilla upstream clusters. But you can also swap that out. For example, I know the folks at Talos Systems have built their own Bootstrap provider that allows you to stand up clusters that are based on Talos OS, which uses an actual API to bootstrap Kubernetes instead of kubeadm. You also have the infrastructure controller manager here, and this is where you have the different providers for the different infrastructure providers. And then the control plane controller manager here is something that was introduced in the V1 Alpha 3 version of clusterAPI. And what this does is it gives you the ability to manage a control plane. So before V1 Alpha 3, if you wanted to manage the control plane of Kubernetes with clusterAPI, you had to really manage it external to clusterAPI. This provided the ability to actually manage a kubeadm-based control plane by default, but similar to the other extension points, you can drop in your own control plane manager if you wanted to manage a different type of cluster that's not kubeadm based, for example. But this handles not just the initial bootstrapping of the control plane, it also handles scaling of the control plane, deletion of the control plane, and that sort of thing. And it does it in a way that protects the control plane. So by default, it's a stacked control plane with both etcd and the control plane components on the same host. And what it'll do is it'll prevent you from scaling the cluster up or down in a way that would cause you to lose quorum for that etcd cluster. So it will only scale up as much as it can without causing that loss of quorum, and the same thing with scaling down.
Yeah, Jason. So I think that's the kind of right introduction for the cluster API, and also you might want to do in presentation mode so that you can. So let's take a couple of questions. So Andre has a couple of questions. Like, what is the benefit of cluster API in comparison with Terraform and Ansible?
Yeah, so to give you an idea, my first foray into building like installers and upgrades and basic lifecycle management for Kubernetes clusters was actually in Ansible. I helped build out the OpenShift v3 installer. And one of the challenges there is I would say that Terraform and Ansible are really great if you're building something that is highly opinionated. Once you start looking at how do I deliver something more generic for like a product or for like a tool like clusterAPI where we want it to be a building block for other things, it can get really messy in Terraform and Ansible for how do you expose all of that configurability, you know, all of those conditional statements, all of the loops that you have to build into there to support that gets very hard to manage over time. The other thing is that, you know, if you expose, you know, kind of Ansible and Terraform to users, you get users that start going in and making some changes, and it's really hard to sit there and tell them what is supported for compatibility with those types of things and what isn't. So we made a conscious decision to actually avoid leveraging something like Terraform or Ansible because we needed that configurability, and it's easier to do that in the Go-based code that we're using and operating against the direct SDKs for the various different providers. And that's kind of the rationale there.
Awesome. And another question from Andre. How can you justify an existence of a bootstrap cluster? It needs to be installed and managed too.
Yes, that is correct. If that bootstrap cluster is long-lived. The idea that we have for bootstrapping clusterAPI is you would stand up just a minimal Kubernetes cluster. It can be a kind cluster or Minikube cluster local on your machine, long enough to provision an actual workload cluster. And then at that point, you can use, there's a cluster cuddle command that we publish. You can use that to then initialize the clusterAPI components on that workload cluster that you just created. And then you can also use it to move those resources in a safe way over to that workload cluster. And you don't necessarily need a specific binary to do this. It would be possible to do all of this through native kubeadm commands if you really wanted to, but we really wanted to make sure that we had a way for users to do it safely. because otherwise, if you potentially have two different management clusters operating the same cluster, you could basically have dueling controllers fighting each other, and you don't have that leader election across multiple clusters. So it does things like make sure that it pauses all of the cluster reconciliation on the local cluster before it moves those resources over to the new cluster, and then unpauses them so that reconciliation picks up only after the move's complete. We do things like make sure that the target cluster that we're moving the resources to is in a healthy state before we try to move those resources over, things like that, so that you safely get that migration of the resources in a way that would be equivalent to like a backup and restore to a different system.
Cool. So I hope your both the questions are answered, Andre. We'll take one more. I think Suman's question is already answered. So let's take Digambar's question. So Digambar asks, like, can you explain how underneath infrastructure lifecycle being managed in Cluster API for different providers? It is infra provider responsibility.
So the responsibilities are kind of split. So I mentioned the Bootstrap controller manager and the Bootstrap provider there. That right now, today, basically generates what would be equivalent to user data for an instance that you would inject in. In the default case for the kubeadm provider right now, it generates Cloud Init, but I know we're working with folks like the folks over at Kinvoke on how do we make that a little bit more pluggable so that it can also generate things like their ignition format to be able to bootstrap ignition-based clusters better than you can do currently with Cloud Init. The infrastructure manager is the infrastructure provider has two different components right now. There's a cluster component of it and a machine component of it. The cluster component's responsible for doing things like shared cluster infrastructure for that type of environment. So in the case of AWS today, it does things like provisions of VPC and the subnets that you need and the NAT gateways, all of the fun things that you need to actually make the infrastructure work for that Kubernetes cluster. For the Equinix Metal environment, we create a elastic IP for the control plane that can be used to provide a single API endpoint for the Kubernetes cluster that we're provisioning, that type of thing. Then on the machine side, it's basically only responsible for bringing up the equivalent of a machine instance, whatever that is for the provider. So in AWS, it's basically an EC2 instance. It takes the generated Bootstrap config that's stored in a secret and populates that in the user data and creates it. So, we try to keep the responsibility where it makes sense. How do you scale up what would be a machine deployment, which is basically how you manage a group of machines in a declarative way, similar to Kubernetes deployment. That's used in a way so that it's responsible for the scaling up and scaling down and the rolling out of changes. So we try to keep the responsibilities for the individual provider components that need to be done as minimal as possible.
Cool. So I think that's pretty amazing. That's why Cluster API, is being used in production at a lot of places, and that's why even all the books that you read, like Production Kubernetes, and other folks talking about Kubernetes in production, they definitely talk about Cluster API because of the power and the management, the way it manages the other Kubernetes cluster, that it gives you the power of all these management things that you can do with it. So yeah, let's keep going, Jason.
Yeah. And it's been a while since I went through the slide deck, so I apologize. Oh, okay, yes. I did allude to some of this before. These are some of the high-level resources that we have in Cluster API. We have the cluster resource itself, which allows you to define the high-level resources for the cluster. At the basic lowest level of Cluster API, everything is generally a machine. And I say that generally because there are some cases where there aren't, especially if we're talking about like managed Kubernetes providers and auto-scaling groups, that sort of thing. But in the simplistic case, the lowest level primitive is a machine. And in the early days, you had to define all of these machines by themselves. But then machine sets were introduced that allowed you to basically manage multiple machines in the same way that a replica set is used to manage multiple pods. And then, machine deployment, again, a way to declaratively manage configuration and roll out changes to a group of machines through the machine set interface. Machine health check, that's something that was introduced also, I think, in the V1 Alpha 3 timeframe that allows us to actually monitor the health of systems so that if a node becomes unavailable over a period of time, then it can automatically mark the machine as unhealthy, and we can start remediating those actions in an automated way. And similarly, with all of this, we get into where do all of the providers come in and all of that stuff. And I already went into that a little bit and showing the control plane here at this one. So, at the end of the day, the idea is again, that declarative management. One of the things that I didn't really mention is that when we start getting into the configuration of these clusters, one of the big goals was not to try to provide a cloud abstraction to rule them all. We weren't trying to provide, some type of major cloud abstraction interface with clusterAPI. And if you look at it, there's, one of the initial things that people say about clusterAPI when they look at it is there's a whole lot of different types that you have to deal with when you're talking about clusterAPI. You don't just have, one cluster type and you say, I want an AWS cluster with an HA control plane and, 10 worker nodes, and it goes off and creates it for you. And one of the big reasons for that is you can design those nice interfaces if you can be super overly opinionated with how you expect all of those things to look. And we wanted to be able to provide the infrastructure providers and the bootstrap providers and the control plane providers a way to expose things that make sense for them without trying to overly abstract it and make an abstraction that works for all of them. So you have the very generic config exposed in the common types, and then you have very infrastructure specific config that you have to define in the infrastructure specific types. All of the kubeadm related configuration for your cluster goes in the bootstrap config. Things that are related to the kubeadm control plane provider, how do you sit there and differentiate the initial control plane instance from additional control plane instances? All that's defined in your control plane provider config. So there are reasons why things seem overly verbose with clusterAPI, but we also don't expect it to be the end-all and be-all of user interface for cluster management. We expect over time you're going to see some of those more simplified, user-friendly tools come into play that provide that super nice user experience of, I just want, a cluster in this infrastructure environment with this size, and it goes off and does all those things for you. We just expect that'll be a layer on top of clusterAPI rather than clusterAPI itself. The other nice thing is as we've seen with things like the cluster autoscaler integration, we expect that more high-level infrastructure management tooling will be able to integrate with things like clusterAPI and be able to start automating more of these workflows for you as well. And the more pervasive we see clusterAPI, I think the more we're going to see some of that high-level tooling be able to come in and do things that you weren't previously able to do unless you specifically did it for your custom environment.
Awesome. So I think that's a pretty detailed explanation of what clusterAPI is and some of its components. It's really exciting project, managing the Kubernetes cluster, providing you the declarative ways basically to, provisioning all the Kubernetes cluster, even upgrading them, and, managing the complete life cycle that we call. And all the other tools, they cannot do this at scale. You cannot create clusters in different infrastructures using different set of tools which already exist. But cluster API makes it possible using the declarative APIs, and you can scale, destroy, or do all these things. And like Jason mentioned, just like the projects like cluster autoscaler, so you don't need to duplicate them. So you can use that with cluster API itself, and prevent the basically the duplication of that. And yeah, I think it's basically you can work with any of the environments, whether it's bare metal or whether it's any cloud vendors. So all these things come into place, and it's a very a declarative approach makes it more neat. And things like just create me a cluster in this provider obviously will be a top layer on top of cluster API. So that becomes like if somebody has to come and take cluster API as it is and build something on top of it for extensive user experience, where you can just choose your cloud vendor and some of the specifications. You just click on the drop downs, and then you get a cluster over there by adding your keys or things like that, giving the correct permissions and the IAM roles, etc. So I think that's pretty neat thing. Now what next we have, Jason? Do we have the demo next, or we talk about some of the use cases and production deep dive?
Well, we see the use cases. We can go into that a little bit. For the most part, what we've been talking about so far is I want to be able to manage clusters for myself and be able to do that sort of thing. And that's definitely one of the use cases that we have. Like, consider I'm somebody that's in a centralized IT department of a large company, and I want to be able to provide self-service Kubernetes clusters to developers in different parts of the organization. You can deploy your own management cluster, give folks RBAC access to that so that they can create clusters using cluster API, or more ideally, a nicer user interface that you're providing them on top of cluster API that gives you, say, all of the IAM configuration that you would need for your specific environment. It would deploy all of the basic monitoring and measurement tooling that you would have for those clusters on top of the cluster API clusters, that sort of thing. But you have that, I'm going to be a central infrastructure team providing this service to users, which isn't too different than, say, like a large SaaS offering that is offering, on-demand Kubernetes clusters for people. That's one use case. Another use case that we've seen is people providing the ability to bootstrap self-managed clusters for people. So just using like that initial cluster API and that bootstrap cluster, I get a workload cluster. I'm going to move this, the management components from the bootstrap cluster to this workload cluster, and just give somebody a self-managed Kubernetes cluster. That's another use case that we've seen. Some of the other use cases that we've seen is we've started seeing folks now building providers for managed Kubernetes offerings. So things like EKS on the Amazon side, or the Azure equivalent EKS managed clusters. So now people are able to actually do things like do common cluster management across their managed Kubernetes clusters and their self-managed Kubernetes clusters, and be able to, do that high-level management around those different, very different underlying clusters where it makes sense for their workloads. Because some of the things that we've seen is, it's really nice to just use the managed Kubernetes providers when you can, because you don't have that initial complexity or management around them. But there are some use cases that you have for applications that just don't fit within those, because you either need to manage the, modify the control plane components to work in the environment, or things like that. So you can actually provide that common management across different types of Kubernetes clusters that way.
Yep. So yeah, I think there are a couple of questions that we can take. Why would you need multiple clusters? What's the challenge when you manage multiple clusters?
Yes. So one of the reasons why a lot of folks choose to use multiple clusters is it limits the blast radius of issues that may happen within a single cluster. So many folks consider a single Kubernetes cluster a potential single point of failure for things. In general, things like if you lose the control plane for a Kubernetes cluster, for the most part, applications will continue working. However, you're going to notice things like you're not able to scale applications as needed. You're not able to roll out changes to applications. So to avoid potential single point of failures with those control plane operations of Kubernetes clusters, a lot of people will choose to use multiple clusters. Or some people consider Kubernetes clusters security boundaries. So they don't want to sit there and have potential issues with applications interacting with other applications on a Kubernetes cluster. So they'll use different Kubernetes clusters to provide different security boundaries for applications, whether it's something like dev versus production or highly sensitive applications versus more less sensitive public accessible applications, things like that. And then the other thing is if you're deploying applications and you want them to be deployed over multiple regions, you can't stretch a Kubernetes cluster across two different global regions. So, a lot of people end up with multiple clusters simply for that purpose, to be able to deploy applications across multiple clusters in different regions, that sort of thing.
Yeah, I think people are loving your the explanations actually because they are very detailed and it's very powerful and it's very clear. So thank you obviously for people for asking them and Jason for explaining them in so much detail. So let's take a couple of more before we dive into other things. Is crossplane same as cluster API?
So there are a lot of similarities with crossplane, but there's also a lot of complementary things about crossplane and cluster API. And to get into it, crossplane is looking to do basically generic management of things in a Kubernetes-centered way. So whether it's cloud type resources in various different cloud environments, or being able to define things like how do you package your application on top of Kubernetes and be able to automate some of the management of that. That's the main focus of crossplane. How do we enable this Kubernetes-centric management of pretty much everything? Cluster API is very specifically about managing Kubernetes clusters. So if there's a choice between trying to offer something overly generic and or something more specific to managing the lifecycle of a Kubernetes cluster, cluster API is always going to err on the side of overly specific for clusters. And so the way that I see things is we're working with the crossplane folks on how do we enable folks to do things like be able to define the infrastructure that they want to manage with cluster API using crossplane. But we're also looking at how do we sit there and enable better integration on the crossplane side and cluster API side to basically say in crossplane, I want a cluster API cluster, go off and do it for me, that type of thing. So I think it's more of a complementary relationship between the two rather than, one or the other. I think there's a very different high-level focus of the two projects, but together, I think it's going to provide a lot of powerful and flexible options for folks.
Definitely, I definitely agree with what all Jason said, because they both are tend to be to complement each other and rather than being in head-on one-to-one. So I think so Jason, how about for till now what we have discussed is we have like what cluster API actually is, what it does, or what is its base architecture and some of the components that you can still see on your screen, some of the components, and how you can use it for multiple provisioning different clusters, managing the life cycle of different clusters, and some of the comparisons like with crossplane and why actually we do need multiple clusters. So all these things. Now, when we talk about production, what do you feel like? What are the different cases, or maybe let me put it this way: what would be the production checklist for a couple of scenarios that you can think of in production ready environment?
Yeah, so if you're looking at production writing environment, I think it's going to be very dependent on what is the use case that you have in mind. And I think probably the easiest to describe would be you have a centralized management cluster providing those self-service workload clusters to users. In that case, the biggest thing that you're going to want to make sure is that the management cluster that you're running is a production ready cluster. So you're not running that management cluster on a local kind cluster somewhere underneath somebody's desk. You want it to actually be a provisioned, managed cluster API managed cluster, or potentially an externally managed cluster. There's no reason why your management cluster couldn't be sitting be managed by something like a managed service provider. You could use GKE if you wanted to provide that management cluster and spin up every other cluster managed by that cluster API managed cluster. So that's the first one. The next one is you're going to want to make sure that you're taking a proper backup of that cluster. And for that, you're probably going to want to make sure that your management cluster is backed up using a tool specific for Kubernetes backups. One of the mistakes that I think a lot of people make is thinking that being able to do etcd snapshots and restores is sufficient for backing up and restoring a Kubernetes cluster. And the problem that you have there, and especially with something like clusterAPI, is that that state of etcd may not necessarily reflect the reality of that Kubernetes cluster at that point in time. You could have some external state that's happening at the same time, and it's not captured in that etcd backup. So you really want to make sure that you're using I see somebody in chat mentioned Valero. Valero is definitely an option there. I know there are some other tools that do it as well. But you can also potentially do it using just something simple as some type of GitOps workflow environment that's storing those resources in the proper way so that you can restore those resources as they were intended to be on that management cluster after the disaster recovery scenario happens.
Cool. So yeah, I think we have enough of the enough of the knowledge to basically dive into the demo and see it in action, because now we know some of the concepts and what it actually is, what it does. So we are kind of ready to see it in action.
Yeah. So before I actually get too far in there, let me see. And part of the reason why I avoided presentation mode for this is because I'm not actually going through the deck all the way here, and I'm trying to skip through. But before we get into the demo, I want to give a little bit of background on Tinkerbell, because the demo that I'm going to show is actually using Tinkerbell to manage bare metal infrastructure that I have here locally with me. And if I switch over my camera, you'll see over here is my basic local environment here. We can call it US DeTiberus East if we want to. We got 5 small form factor machines over here, and we have this larger machine on the right. That's actually the machine that's hosting Tinkerbell for us. So let me switch back over to this view so you can still see that hardware and you can also see me. But basically, Tinkerbell is basically a project that's trying to bring that declarative style management that we have for Kubernetes for applications and now Kubernetes clusters, but try to bring that to actual management of physical infrastructure in a data center. And the way that it does that, it's not just a single monolithic application. There's various different microservices that are involved to make that happen. The most important one of those is the main Tinkerbell workflow engine service. And that's where you basically define the hardware that you want to manage with Tinkerbell. And you basically define what we call templates that you can apply to workflows. And basically what you're doing here is basically just giving it a set of steps that you want to perform on some specific type of hardware. So you define that in the template, and you create a workflow that basically just links a specific template to a specific piece of hardware so that it can actually run those steps that you've defined. There's also several other components. So in this case, there's this boots component here that provides the basic DHCP and Pixie boot environment, pre-boot execution environment, so that you can actually boot into what we call an operating system installation environment OS image that is capable of running the worker component of Tinkerbell, reaching out to the Tinkerbell workflow engine and saying, do I have any active workflows and what steps do I need to actually run on this particular hardware when I boot up? And that's pretty much it for the high level view of Tinkerbell. And how does that tie into something like clusterAPI? Well, in this case, we have a Tinkerbell cluster resource. We have a Tinkerbell machine template and Tinkerbell machine resource. And that's all we need to define on the clusterAPI side. Right now, Tinkerbell is purely implemented as an infrastructure provider for clusterAPI. And when we do this, we have the predefined hardware resources that we have. And then we have the Tinkerbell machine, when it's created through either the machine deployment or the kubeadm control plane, it's going to create a template and a workflow inside of Tinkerbell, and that's going to cause things to actually happen. So if I switch over to this window, what we have here is I'm in my IDE. I've already stood up a local kind-based management cluster. Don't do this in production, please, but for the purposes of a demo, it's perfectly fine. I've deployed both the core clusterAPI components and the Tinkerbell provider components to that cluster. And I've already stood up Tinkerbell and predefined all the hardware that I'm expecting to use inside of Tinkerbell. So if I come in here, what I need to do on this side now is I have this YAML file here that is basically just going to tell the provider about the hardware that I predefined in Tinkerbell. So it's not going to automatically assume that it can use all of the hardware that Tinkerbell knows about. It's only going to touch hardware that I'm telling it I've set aside for its use. So if I create this. Okay, so now that I've let the Kubernetes cluster know about that, I can do a get Tinkerbell here. I see the hardware there. And let me actually just describe that. We can see now that while I only specified an ID of the hardware, I'm now seeing a lot more information about that hardware. So I can see that, in addition to just the ID that I'd find in the spec, I have a whole status here, and this is all information that was predefined in Tinkerbell for this hardware. So the things that are important to see here is that I have a disk device tied to each of these pieces of hardware, and this is what tells the Tinkerbell workflows that are created where to write the OS image when bootstrapping these clusters. I have the IP and other state for the various different network interfaces defined here. And I also see that there's some type of metadata that's defined for this. And I realized that I forgot to describe the Hegel metadata service when I was talking about Tinkerbell earlier. There is also a metadata service that's available similar to the metadata services that you have in most cloud environments, so that when we're doing bootstrapping, we can leverage things like Cloud Init, reach out and get information about that metadata at bootstrap time. And the clusterAPI provider here for Tinkerbell will actually be injecting that bootstrap data into that metadata as user data the same way that it would in, say, AWS or another public cloud provider, so that we can consume that on the host at bootstrap time. So this bootstraps the same way that like a cloud environment would. It's not, we're not doing anything special by injecting things at runtime when we're writing the image to disk or anything like that. So that hardware is created. The next thing that I can do is create a cluster, and I am actually going to have to copy and paste a command here because I need to override some variables. My local environment here, the network that I'm using is 192.168.1.1. And if I didn't override this, it would conflict with the default pod CIDR that the cluster would get. So in this case, I'm using this to override the pod CIDR to a non-conflicting IP space so that the cluster doesn't, the cluster actually works when I provision it. So at this point, I've created the cluster. And if I do this, get the clusterAPI resources for it, what I can see now is that I have this Tinkerbell machine here for the demo cluster that I've created. It's saying that it's ready, but this definition of ready right here basically just means that it's defined the template in the workflow needed to bootstrap the instance. And it's telling me the instance ID that's assigned to this machine is this right here. And I've cheated a little bit and made sure that the IDs are easily identifiable for me here. So I know this one ending in A refers to the hardware that I have over here labeled A. So let me just power that on real quick. So while that's going, what I can do now is I can actually show that if I do a get Tinkerbell here to see all of the Tinkerbell related resources, I can see that in addition to that hardware that I've defined, I now have a template and a workflow defined as well. So if I describe the template, what I see here is this goes into that workflow that we talked about. So within the spec here, we have a set of tasks that are defined. And for each of these tasks, it's one step that this thing's performing for us to spin up this cluster. So the first action that we have here is the stream action, or the stream image action. And what it's doing is it's using a pre-published action that we have. There's actually an action hub where you can basically consume some predefined Tinkerbell actions. In this case, the image to disk one is basically going to take whatever image URL I give it. In this case, it's this pre-built Ubuntu 2000 or 20.04 Cube version 1.18.15 image that I've pre-built with the image builder project, which is related to the clusterAPI project in that it's a tool made to pre-build custom golden images for use with clusterAPI. I'm telling it that I want it to write to this destination disk and that the image is compressed, so it knows to attempt to decompress that image. But this destination disk here was actually pulled from that hardware information that was predefined in Tinkerbell. So from the clusterAPI side, we don't have to do any type of guessing of where do I need to write this hardware image to and like pre-detect it, because in this case, I'm using hardware with eMMC devices, but somebody else, their disk could be like SDA or HDA, depending on what type of disk interface it's connected to. The other thing that we're doing here is we're writing a file to disk, and this is the only thing that we're doing kind of custom right here between the Cloud Init config and this initds config. And this is because Cloud Init doesn't know anything about Tinkerbell right now. So we're telling it to basically treat Tinkerbell and the Hegel metadata service specifically as an EC2 compatible data source. And we're telling it where to contact that data source at. So we're telling it we want it to use this metadata URL to talk to it instead of the default metadata URL for EC2. And we're telling it, you know, this isn't going to look exactly like an EC2 metadata. So ignore that and go ahead and keep processing things. Similarly here, we're doing the same thing. We're just telling it to use EC2 type data source. The other thing we're doing is we're also injecting a default user, and that's just for the purpose of troubleshooting. So if I wanted to, I could have modified the cluster YAML that I applied. I could have told it to apply an SSH authorized key to this user And if something went wrong, I could then SSH into the machine. As it stands now, I didn't do that. So we're going to hope that things work as they're expected to, because otherwise I'm not actually going to be able to SSH into this machine and troubleshoot it. The last step that we're doing is a kexec action. And this is basically just telling it to load the kernel from the block device that we just wrote to. And this avoids us having to do things like reboot the machine in order to actually go into it. So it only takes as much time to start the bootstrap or start the machine up, however long the BIOS and EFI system takes to initialize, boot into the in-memory OS, talk to Tinkerbell, say, run these actions, stream that image to the disk, write these files, and then kexec into that. So if I had fast hardware, that would happen in probably the matter of a minute or two. In this case, it takes a little bit longer for this hardware. So at this point, I can go ahead and see if we've made any progress here. And it looks like things are still going. We're sitting at about 5 minutes and 29 seconds. So I expect it probably still needs a little bit more. But while that's going, what I can do is go back to here. I can go ahead and get my kube config. And let's issue this get nodes command here. Oop. Do it in the terminal. We can see that actually the node is ready at this point. So in the amount of time I took explaining that, the machine actually did finish coming up. It is showing as a control plane instance right now. So let me go back here and deploy a CNI solution. And once that's deployed, we'll be able to see that that node will eventually become ready. And at that point, we can go ahead and scale things up if we want to. So that's most of the demo right there for the initial control plane. Until that CNI is deployed, I don't really want to test things too much by scaling up any actual workers, but I'm happy to take any questions while we're waiting for that to come through.
So first of all, Jason, like it was a very clean demo. Usually on the live stream, it's somewhat we have to figure out how things should work. But yeah, it was a super clean demo, and I think it worked really well. And it was very you explained it really well, like how what Tinkerball is and how how it is getting used with the cluster API. So I think now the people who are watching the stream right now or will be watching later, you have some idea like how it's easy to manage the clusters with the cluster API, how the cluster API plays important role when you are defining some of the resources, because it's a declarative way of defining the the machines and how things will work, how the clusters will look like. So I think that was a very neat a demo as well. And I think all the masters is ready, and the CNI is also deployed correctly. So all things are working, which means we have a very good demo. And so the last aspect of the stream is always about the community, which is actually the core part of CNCF ecosystem, to be very honest. Jason, can you talk a bit about the community aspect and how folks can get involved in cluster API, because this seems to be very exciting project, and because it is being used in for the personal space, for the production use cases, for at edge devices, for the bare metals. So everywhere it is getting used. So how the community can get involved in it, and what all things can they contribute to? Just a bit you can touch on.
Yeah, absolutely. So probably get folks up to speed with what I was doing while you were going there. I went ahead and I scaled the machine deployment up to 3 worker nodes. I saw that which pieces of hardware were assigned to those. I went ahead and powered those on. So those will continue to come up here as we continue. The other thing is this demo only went smoothly because I've done it a few times now. The last time I actually tried to do this demo live, it actually went up in flames. So I was quite happy that everything proceeded as it did. There is just as much chance of something being wrong with this demo as any other. But as far as how folks can get involved, and let me just go down here, and basically, we're looking for contributors of all types. We're not necessarily looking only for code contributors, although code contributors are great. If you are good with documentation, we are definitely looking for folks that are able to help us improve the documentation that we have. Are you good with like product management skills? We are more than happy for folks to sit there and do things like gathering use cases, refining the use cases that we have, defining different types of personas for the different use cases that we have within clusterAPI, and things like that. We always need people to help us with the backlog grooming and milestone maintenance that we have. So if you do have those product management skills, please, please, please let us know. We are more than happy to help you get involved there. For code contributors, we have issues that are out there both on the clusterAPI repository and all of the different infrastructure providers and various different provider repositories. We try to mark ones that are, aren't actively being worked on or are expecting we're going to need folks to come in and provide help with as help wanted. We try to make sure that we have some that are marked as good first issue. All of those should be very, very detailed in what the problem is and what do we expect is the way to solve those problems. So if you're not entirely up to speed on those projects, those good first issues should be very good ones to dig into. And nothing else. We have our weekly community meetings. We have a Slack channel. We have the mailing list. And I will make sure that this slide deck, there's a link to it so that everybody can access the quick links in there. Everybody that I know in the community is more than happy to help mentor folks into the project, answer any questions that folks have and all of that. So while I know it can be highly intimidating, and there's a lot of complexity involved here, please don't let that be overwhelming for you. We are here to help minimize that as much as possible. And it is not an imposition at all. We are happy to answer your questions about these things. And I do see that somebody in the chat mentioned that there is a Metal 3 project that also uses clusterAPI. Yes, indeed. There are other folks that are doing things in the bare metal space as well. So I don't want to make it seem like Tinkerbell is the only solution there. It's just our take at the solution and how we can attempt to continue iterating on the space. And we look to collaborate very much with the Metal 3 folks in the future on sharing both of our experiences and ultimately, at the end of the day, everybody has their own perspective and everybody's going to make their own mistakes. And hopefully we learn some good lessons at the same time and we share those lessons and then everybody benefits from those.
Awesome. So hope you get some insights like, there are different ways that you can contribute, which is very important. That's why I always bring this topic. So there are different ways that you can contribute to clusterAPI project. And obviously, awesome. Jason is there and he'll be able to help you out. And the other folks in the community will be able to guide you on, some of the things like go here, you can learn from here. If you want to, do a quick start, you can do here. So all these things are there. There are a lot of amazing talks out there on clusterAPI, obviously, that you can see. And I hope you got some of the production insights, some of the use cases, which are very important. Why multi-cluster is important, why people are using multiple cluster, how it is important to manage multiple clusters, the life cycle, the complete life cycle using clusterAPI, how there are different, cloud infrastructure providers are pairing up with clusterAPI to make it, more a streamlined kind of thing. So, and people are definitely using it in production. If you go through the production Kubernetes book, there is a big mention of Cluster API and its use cases. So make sure you can just read that book. It's really good. And so that's why it's important to know about cluster API. If you are a Kubernetes enthusiast, or you just are a person who spins up Kubernetes cluster or do a lot of R&Ds on that, so I think this is a great project to be involved in. So what we'll do now is I promise, like, there will be one swag giveaway, and I have 31 entries, 32 responses to be honest. So let me export that in Excel real quick so that I have the numbers. Okay, so I have done that. So now what I'll do is, Jason, just pick a random number, and I will just then speak out the winner name.
All
So the
right.
random number between 1 to 33.
Let's go with 17.
Okay, let's go with 17. Okay, so it's Kishore Kumar Behera. So Kishore, congratulations on winning this swag. So this one is basically about the sorry, the CNCF store. So you can go to store.cncf.io. I will be sending you the coupon directly on the information that you provided in the form, and you'll be able to buy the swags from there. So it's a $30 coupon, and you can buy swags, awesome swags. Do not forget to tag us, the stream, and also the CNCF for doing this. So thank you to CNCF for supporting me, so that it gives enthusiasm to you also to attend these streams. And yeah, congratulations, Kishore, and thank you, Jason, so much for your time and spending your time on Cluster API. You explained, I mean, a lot of concepts. There were a lot of slides, but you picked the right ones for this particular stream, which is amazing. And also all the other things that were on the agenda were covered very beautifully, and a very neat demo, which on a live stream. It's superb to see that kind of neat demo. So really awesome demo. So again, thank you for your time and explaining about Cluster API, production use cases, architecture, and so on and so forth.
Absolutely. Thank you for having me.
Okay, so there are a lot of streams coming up. Do not forget to subscribe to the channel if you're watching, and make sure you subscribe and press the bell icon. There are awesome stuff coming up, and I'll do these giveaways in each of the stream. So make sure you subscribe to the channel. This keeps me going, and see you next time. Okay, bye.